So this is the 2019-2020 exam paper, and let's go through section A. We have to fill in the appropriate words in these blanks, and as you can notice, the questions usually are recurring, so we might have gone through the same questions in previous videos, but let's do it anyway. When a Java program is compiled, the bytecode produced has a file extension called dash. So this file extension is called .class because when you compile a Java program, what you get back is the bytecode, but it's saved in a file with an extension of .class. Maybe I could try to demonstrate this. Let me just clear all this. Where are we? Okay, let's create a simple Java file. I'm going to call it hello.java. And then I'm going to let me just, what can I do? Okay, let me use Vim. I'm going to add some code to this file, and it's going to be a public class called hello, and it's going to have a main method, of course, public static void main with string. We are used to this being args, but let's use like ABC. Then I'm going to have a simple printout. I'm just trying to demonstrate bytecode, what bytecode looks like. Hello world. Okay. Let's not mind about the formatting too much. Just leave it like that. So if I save this, how do I exit Vim? Yeah? Yes. Okay. So if I compile this, before you can see, where is it? It's here, hello.java. So if I compile the hello.java file like this, hello, if I compile it, it's successful. Now when I list my files, I should see hello.class. That's the compiled what? The compiled code, which is bytecode, saved in this hello.class file with the .class extension. Okay. Yeah, I've forgotten how to show bytecode. I would have done that. I don't know if this will work, but let's give it a try. Hello. Yeah. And there, oh yeah, yes. Okay, whatever that is. Hello. What's happening? Come on. My terminal's frozen. What a shame. Okay, let's quit that very stubborn terminal. What if I just use the normal one? Terminal. Okay. All this hassle. Okay, so we have our hello.class. So if maybe this is the one to show me the yeah, what is I keep messing up and pressing tab, then the thing crashes. Sorry. One last time. Okay. So if I java p, yeah, I think that's the command, and then I hello dot class bytecode. Yes. So yeah, that's our bytecode from our hello.java file. This is the compiled, what the compiler reads. Yes. Okay, let's go back to the question section A. So here we have dot class as the answer. B is dash is a program that converts Java bytecode. So the bytecode we've just seen, they're looking for a program that converts that Java bytecode into executable files and helps to make Java programs platform independent. So this is the Java virtual machine, the JVM. So you can just simply write JVM, Java virtual machine, which is the program that takes your bytecode and makes it executable and platform independent, such that the code can run on multiple operating systems. So you write your code once and then you can run it on multiple operating systems using the JVM. C is dash is an object-oriented programming concept that provides for objects to be self-contained. When you see self-contained and you see objects, just know that is encapsulation. So basically, if you think about something like a capsule, those tabs that we take when we fall sick, like they are encapsulated, they are within some kind of container. That's why they call them capsules. Right? So when you encapsulate something, you're hiding the inner contents from the outside environment. So yeah, basically that's encapsulation in Java. So D is dash is a method within a Java class that has the same name as the class, and such a method has no return type. Okay, so this method is what they call a constructor. So a constructor is a special method in Java that has the same name as the class, and such a method has no return type. So a constructor is the keyword here. E is dash is a Java keyword used to distinguish class variables from instance variables. This is static. Static is the keyword used to distinguish class variables from instance variables. Let me try to demonstrate this one. So if I have a class, I'm going to call example. You're going to demonstrate class variables and static class variables from instance variables. Okay. So what is a class variable? A class variable is something that is defined like this: static integer age. That's a class variable. This is a class variable, meaning, let's get rid of this, meaning it belongs to the class. Then an instance variable is a property that does not have the word static. This becomes an instance variable or instance field. What's the difference? So the difference is, if I create Let me show you the constructor as well. The constructor that we discussed in this one. D is a special method in Java that has the same name and there are no return type. So that's the constructor. Same name is the example, same name as the class. So public example. And then it takes, it returns it returns nothing. Like it has no return type. There's nothing like void or int or double or whatever. No return type like this. It doesn't do that. So its main role is to construct objects, which I want to demonstrate here. Now we have a static int and an instance property called height. So I won't do anything with this code. I just wanted to show you how constructors look like. So if I have a main method and I create objects of type example, I'm going to create 2 of them. So I have obj1 and this is a new example, and I also have obj2, which is also a new example, like that. So if I set obj1 dot age to 29, then I try to print out the result of object 2. If I try to print out the result of object 2 and access this edge here using this second object obj2 like this. Wait, what's not happening? Oh, okay, that's not how you access static methods. You access static, not static methods, static fields using the what? Using the class name. So I want to access the static field like this. So which also means, okay, this works, but it's not recommended. You have to use because it's a static field, you have to use the class name like that. My like that is not working, like that. So the error goes away. So if I set the static field like this, already we are seeing differences of how you can even set the fields themselves. Here we are using the what? The class name, not the object what? The object, not the object we have created up here. So I'm doing all this to show you that this, when I try to print this out, I'll just get I'll get 0 because int is not initialized to anything. Oh no, it's initialized here to 29. So I'll get 29 like that. Okay, now my example is running away from me because I wanted to demonstrate what happens when you try to access the static field using the object, which you cannot do. Okay, so that's the difference. you cannot access static fields using, okay, you can, but no, accessing you cannot. Wait, because this is also accessing. This is accessing. You see, static member accessed via instance reference. Okay, so you can access, but then it refused to access here. Oh, where are you? There. Oh, okay, nice. Okay, it refused to bring it as a suggestion like this because Java does not recommend doing this. So if you typed it out anyway, it would run, it would compile, but IntelliJ is saying something is wrong here. So let me demonstrate what I was on to. Cutting. Here, object 1 sets age to 29. Now what happens when I try to access age using object 2? I should get what? 29 because it has been set to 29 here. So if I run this, running, So if I run that, I should get object 2 as what? 29. That is static fields in action. Now, if I use the height, because height is what? Is an instance field, meaning the variable belongs to the, okay, let me first explain static. Static means that variable belongs to the what? To the class. So if you set it anywhere, let me also do this. So static means there's only one copy in memory. There's only one copy of age in memory. So if I set age in memory somewhere as 29, then whatever tries to access this age will have that value, or whatever sets this age to any other value, anything else that tries to reference this age will have that value that it has been set to, or that current value that it has been set to, which in this case is 29. That's why you're getting 29 here, because age belongs to the what? The class. This entire class, like it belongs to that entire class, not to the individual instances or the individual objects, which I'm going to demonstrate later using the height. So if this was height and we were setting height, not age this time, see this one compiles nicely, no error. So if I set the height here to 29, and then I use the second object to try and access what height is currently set to, which we think is 29, but that's going to be wrong. It's going to print what? 0 instead, because when we create this object here, height is 0. So when this object tries to access the height property, which is this one, it will read it as what? As 0, not 29, because this height property does not belong to the entire class. So it only belongs to the instances. So if we run this, we should get 0. Not should, must. We must get 0. So you're getting 0 there. So think of static as your dad's surname. So your dad's surname is set once. You're born with that surname. Everyone else is also born with that surname. So if your dad, maybe somewhere along the way, changed, does that work? When your dad changes his surname, you're also okay. Maybe you get what I'm talking about. Basically, the static field is set once, or not set once. It is set in only one place in memory. So whoever accesses that reference gets that current value that is stored inside there. Unlike the height, where this belongs to the object, to that instance. You can give yourself your own nickname, something like that. Okay, let me hope that made sense. Okay, let's go on to where were we? F. Dash is a keyword used in Java to define constants in a class. How do you define constants in a class? Basically, the only word you need is, let's take this one, final. That's the only word you need. Now, by making this field final, Java is complaining. It's like, we have made this final, but we have not given it a value. So if we give it a value, like the constant height is 174 centimeters, because I am 174 centimeters. So if this is, am I 174, 184? I don't know, I don't remember. So so now this becomes a what? A constant, because we have made it final. So final means we have put a stamp on this variable name here that no one else should change it. no one else must, no one else should change it. That's why when you come here and you try to change this height to something else instead of 174, Java is going to be like, no, we are final, we cannot assign a value to the final variable height. So that's a final variable. All you need is this keyword, but in some libraries, or in some code that you might read somewhere, you can find, or you will most probably find something like static final. So this is another way of defining constants in Java. Actually, it's, I think the preferred way, because once you make something static, then there's only one copy of that thing in memory, and now you're saying, okay, it's also final, so it cannot change. And this enables you to do something like, instead of creating an object, like instead of creating this entire 2 lines of code, you can just say example.height. Oh, this is, you can't say it, so you can just access it. So you can just say, you can get rid of those 2 lines and access it like that. See, simple. So another benefit of using static. So that's final constant, rather constants. Basically, it's recommended you just use static final, because you can get to do stuff like this. Okay, so we have a static final constant, and here you can either use final, you'll get a mark, or you can say static final. They even say the keyword, so final is enough. So you have G dash is the collection of related classes in Java. So if you have related classes in Java, that collection is called a package. Now when you come to our project here, we only have one class, so this entire thing is in one package. But if we try to create another class, so these 2 classes will be related, and they will they are contained in a package. This is the default package because they have no package name. Basically, you create a package like this. You come here, give it a name, something like what? Now we have a package. So whichever classes that I create inside here, me, and what else? You. So now these classes are related because they belong in one package. They are now a collection of classes that are related and belong to one package called Majaliwa. See? So that's G. A package is a collection of related classes in Java. Then we have H. Dash is the ability of an object in Java to appear in different forms based on the environment it is in. So this one, when you see forms and different, you just have to think of polymorphism, because poly means many, and morph is form. When something morphs, it deforms, or it is formed, I don't know. So polymorph, many form, polymorphism, many forms. So we can maybe try to demonstrate polymorphism, and we can do that using a simple class. Let's use this one. So polymorphism. Polymorphism. Okay, so if we have a method, public void locomotive. Okay, so we have that method there, and you know what? Let's make this animal to make things make sense. Which means I have to change this to don't freeze. change this to animal. I'm an animal. So animal is locomote, right? So if I have some subclasses here down here, like a dog, which extends inheritance, which extends animal, but I'm trying to demonstrate polymorphism. Kind of can't do that without inheritance. So yeah, if I try to override this method here, public void locomote, here the default one is going to be I move, but my dog runs, so dogs run. Now if I create a method here and I create an instance of dog, of type dog, new dog, all this to demonstrate polymorphism. Okay, dog dot locomote. So I can also have here. Does that make sense? What if, okay, let me just create something inside here. An animal called animal is equal to a new animal. This animal could be anything, could be you, could be a cow, and this animal locomotes as well, like that. So we have one thing, which is this method here. This method being called like this, being called in the same manner, dot locomote, but it's going to behave differently depending on the on the environment or the context. Here the context is this is a dog. Here the context is this is an animal. So if I run this code, I should get dogs run here, dogs run, and here I should get I move. This is what polymorphism. You have the same object. Is that what they say? An object to appear in different forms. Okay. So we have this dog object calling the locomote method, and this animal object also calling the locomote method. But if I try to run the program, I get what? Different results depending on the context of the object. Here it's a dog, here it's an animal. Polymorphism. So polymorphism is the answer here on H. Dash is the ability of a Java class to take on properties and behaviors of another class. Okay, we've done this by mistake somewhere, and this is called inheritance. Inheritance is the ability of a Java class to take on properties and behaviors of another related class, which we have just done here with polymorphism. Inheritance is the ability of another class to take on behaviors of another related class. So this class dog here took on this behavior here, like you've seen here. I move called this method I move because when you inherit, you take on the behaviors, so you can basically have access to this method as well, as long as you extend and as long as it's public. Inheritance. Where are we? J. In object-oriented programming, dash are used to model the behaviors of objects of a class. What do we use to model behaviors of objects? We use what they call methods. So you come here, you have your method, then you say, what is my method going to do? How am I going to describe the behavior of this animal? This behavior, this animal moves, but how does it move? I move rapidly. Okay, so yeah, this is how you define behaviors of what? Of a class by declaring and defining methods. So basically the methods are the behaviors, and then the properties, like we saw in this other example, these become the what? The fields or the characteristics of the class. But the behaviors are these things here that you define in curly brackets. Yeah, okay. So okay, dash is the Java keyword used to indicate that class A is a subclass of class B. Nice. Guess. Dash is a Java keyword used to indicate that class A is a subclass of class B. That class A is a subclass of class B. This is extends. So subclassing is inheritance, and you do inheritance using the extends keyword. So extends is a Java keyword used to indicate that class A is a subclass of class B. So class B is the parent, class A is the child. Dash in object-oriented programming is a combination of the return type, a combination of the return type, the name, and parameter list of the method, and is used to uniquely identify a method in a class. Interesting one. So short answer, this is method signature. Or rather, sorry, it is method overloading, because yeah. Yes. So method overloading in object-oriented programming is a combination of the return type, the name, and parameter list of the method, and is used to uniquely identify a method in a class. Okay, yeah. Now, no, method signature. Let me explain. So basically we have another class. Let's call it signature. Signatory signature. So we have, okay, method overloading still is same, not same thing, but we have method signature and method overloading, but I'm trying to find out which keyword we have to write here actually. Okay, let's decide this. So we have a public method that returns nothing, and it is called let's use add, simpler. Add, like that. We have another method, but this time it's private. It returns an int, and it's also called add. So see, when I do it like this, when I have different access modifier and different return type, but same method name and same parameter list, which in this case is nothing, we get an error because we are not overloading. So basically overloading does not care if you have different access modifiers or different visibility modifiers. Overloading does not care if you have different return types. It only cares if the name is the same and the parameter list is is different. Let me demonstrate this. So if I do something as simple as int x, everything compiles. Okay, it does not compile, but because we are returning an int here, so we have to return an int, say 2, like that, to make everything compile. But remember, when I showed you earlier, it doesn't care if, okay, maybe you don't believe me, because here it was not compiling anyway, because we had an int. So let's make this yeah, anything else will require return. Okay, let's make it void. Still we get an error because overloading does not care the return type. So yeah, so let's use double this time again. Double, still get an error here. See, the error is here, it's not on the entire thing like it was before. Not on the entire thing, it's only on that bracket. What's the word? I've lost the word. Showing you that there's a missing what? Missing return statement. So when we return a double, 0.0 is a double, the thing goes away. But now the error goes back to this thing, to this entire declaration. It is like, man, these things are the same. Add is already defined in signature. It is already defined up here. So how do we make it undefined? How do we overload it? We overload it using, since we're returning doubles, let's use a double y. And that is overloading. So here they are saying a combination of the return type, name, and parameter list. But now me, I'm saying we don't need the combination. We don't need this combination of the return type and the name. We just need the what? Okay, the name and the what? The parameter list. Because these combinations here don't matter. So basically I can have something like a default access, which is no access modifier, and I can decide to return a string, and the method is still add, and string, because we are doing with strings, and this is now return what? How do you return a string? Just return some empty string like that. See? Overloading, no errors. Why? Because here we have add, the parameter list is a double. Here we have the same method add, but the parameter list is what? A string. These are different parameters. Here you're dealing with doubles, here you're dealing with what? Strings. That is method overloading. But if we had double here, double y, double x, whatever, doesn't matter, it will be an error. That's not overloading. Yeah? Okay. So here, now what goes here? Is it method signature like this, or is it overloading? Method overloading. So dash in object-oriented programming is a combination of the return type, name, and parameter list of the method, and is used to uniquely identify. So what do we use to uniquely identify a method in a class? We use the signature. Yes, so the answer is signature. So a method signature is used to uniquely identify a method. Get rid of that method in a class. There. So we are using a method signature here to uniquely identify this method. We are using a method signature here to uniquely identify that method, and we're using a method signature here to also uniquely identify this method, because method overloading doesn't care if it's a string, if you're returning a string, if you're returning a double, returning a nothing, if the access modifiers are different, doesn't care. All we care about is the name the same? Yes. Are the parameters different? Yes. Then you've overloaded. Okay? Yes. You've seen it with your own eyes here. What next? Part 2. Okay, part 2. Okay. Yes, part 2. Mr. Opio runs 2 types of business in Ngulu City, namely a timber store and a unisex salon. Each business pays a fixed daily city council tax of 1,000 shillings. Sorry. So, Mr. Opio runs 2 types of business in Ngulu. You have a timber store and a saloon, and each business pays a fixed daily city council tax of 1,000 shillings. Each business also pays a rent, which is a whole number, and this varies from business to business. So this already looks like a number we've done before, and we are going to have to use inheritance because we have 2 businesses, timber and saloon, all falling under one huge superclass. You can maybe remember the question we had of the lodge, where we had non-residents and residents, and we had the guest superclass. So for timber business, the daily income is determined by the number of timber pieces sold, which is an integer. When they say whole number, this means it's an integer. And the price of timber, a whole number, an integer. And this can vary on a daily basis. So how I like to answer these questions is, as I'm reading through the question, I jot down on the question paper the keywords I find. For example, here I already know when I see Mr. Opiat runs 2 types of business in Gulu, we have timber store and the unisex saloon. Those are 2 classes already. So you have a timber store. You can just note down on the question paper, you have a class called timber, and your second class is called what? Saloon. And each of these businesses pays a fixed daily city council tax of 1,000. So if each of these businesses pays a fixed daily city council tax of 1,000, then this is already hinting at something like inheritance, where you have a parent that is going to have the fixed daily city council tax, and then these children, these subclasses, will inherit from the what? From the city council, from that parent which has the city council tax. So basically, they have access to that same field as well. So you are already avoiding duplication there. Then here we have each business also pays a rent. So here each business pays a fixed daily city council tax, and each business also pays what? A rent. So those are already 2 properties in the superclass. You have the city council tax and the rent. So we also have here, for the timber business, the daily income is determined by the number of timber pieces sold and the price of timber. Then here, for the unisex saloon, the daily income is also determined by the price of the service offered and the number of customers. So meaning these calculations here are independent, so they will belong to the different classes, one for timber, one for the saloon. Okay, for the saloon business, Mr. P also pays a daily power bill. So here they're saying for the saloon business, so you have to go to the saloon class and write this property down, the power bill, which is a fractional value, meaning it's going to be a double. So you'll have something like double power bill, but only for the what? For the saloon business. Okay, so let's go to the questions. You are required to apply the concept of inheritance to do the following tasks. And our first task is define a superclass. So up here, they didn't give us the name of the superclass. It's up to us to come up with one. But you must keep this superclass consistent, because it's going to be used throughout the entire question. So let's create, what should we call our superclass? I'm going to call it OPO. Like that. So yeah, we are defining the superclass now. And remember, when you're jotting down your things on the paper, you can now translate those things to what? To code. So the first thing we noted were the classes here, timber and saloon. But now they are asking us to define the superclass first. And our superclass is going to contain these fields here that are shared by the what? The timber store and the saloon. So one of the first fields is the city council tax. But it is saying here each business pays a fixed. Remember when we were fixing values here with the final keyword. A final is a keyword used in Java to define constants in a class, and this is already a constant because it is fixed. It never changes. So how do you define that constant? Static final. We said static final. What's the constant name? Let's use this actual name here, city council tax. So it's an integer. Why? Because it is 1000. 1000 is a whole number, which is an int. So an int called city council tax. And how much is it? It's 1000. I like to use this thing here. That one, just to properly show instead of using commas, because you can't use commas. So you can do that. Just the next thing is the rent, because all businesses pay the rent, so we can just share the rent here. The rent is not fixed. Here they are saying the rent varies from business to business, so it's not fixed, it's not final. And is the rent an integer? Yes, it is. So int rent, as simple as that. This time we are not going to initialize it to anything, because it's not fixed and they are not asking us to initialize it to anything. They are just saying it varies from business to business. So depending on the business we are using and the objects we are going to create, we shall send the rent from there. So our superclass looks like it's all done, but let's make sure it's actually done. So for the timber business, this is for the timber, this is for the unisex salon. What else? For the salon business. Okay, so our superclass is done. Now they want us to define what? The subclasses. So the first class I'm going to define is going to be class timber. And how do I make it a subclass? I have to extend the superclass, which is OPO. So we go to the properties for the timber class. We are not going to do the city council tax again and the rent, because we already have that in what? In OPO. Remember inheritance. When you do something like this, you're taking on these fields as well. You're inheriting them. So you don't have to type them again down here. So for the timber business, the daily income is determined by the number of timber pieces sold, which is a whole number, and the price of timber, which is also a whole number. And this can vary on a daily basis. So here the trick is to figure out, is to test. They are testing for whether you know how to use properties in a class. So here we have a timber business, and it sells timber pieces at a certain price. So we have in the timber here, we have timber pieces because they are integers. Let's call them timber pieces, like this. And these timber pieces are sold at a price. Let's call it timber price, like that. Now they're asking us to get this daily income. The daily income is determined by the number of timber pieces sold times the price of timber. I guess that's the formula they want. So to get that, I'm going to create a special method called a constructor. And this special method is going to take the same name as my class. It will also take parameters that I've defined, not the ones above, but the ones that I'll use when creating the object. And the first one will be the number of timber pieces Mr. OPO is going to sell, and the second parameter will be at what price? Timber price. So what I'm doing here, these things here, these parameters are not, these ones, they are different. So here integer is even saying there are no usages of this variable name yet. So when I do something down here, you will see this changing to one usage. But currently, whatever I'm typing inside here is not this. So let me go ahead and say, now what I want to do when I'm creating the timber object, what I want to do is to initialize these properties here. How am I going to do that? I'm going to say this timber piece here, these timber pieces, like this. This is how you reference these properties here in these properties of the class. You use the keyword this. So this dot timber pieces is going to be whatever value I get when constructing the object, which is timber pieces, like that. And do the same for the timber price. So here you see the color is now the same. This color is the same as this color. This color is the same as this color. So IntelliJ is making sure you don't get confused. The variables are different. So this can as well be A, and this can also be A, like that. Makes no difference, but for code readability, best to do that. So in order not to confuse Java, because here we have the same variable name and the same variable name here. So if I do something like this, Java gets confused, like which timber pieces do you want me to update? This one, like what's going on? So it's up to you to tell the compiler that I want this, the one above here, this one is the one I want to be equal to whatever is input here. Okay, moving on. So we have this dot timber price, and that is equal to the timber price, like that. And now what is the method for calculating this? The method is going to be, you're going to get this dot daily income. We don't have this yet. Daily income, which is going to be equal to this dot timber pieces, the product of the timber pieces times the product of the price, timber price, like that. So when we multiply the pieces times the price, we must get the what? The daily income, which means here we must have a daily income as well, like that. A daily income property. So this is the timber class for now. There's going to be more. This is for the saloon. Okay. So define a superclass, we've done that, and the two subclasses that can enable Mr. Opio to determine his net daily income. Okay. Consider deductions only mentioned above. So when you are doing your rough work on the answer booklet, in the answer booklet, the deductions you made here, these ones that I was also making verbally, are the ones you should only consider. Don't consider anything else. So we considered the daily income here because it was asked for. That's why we had to create an extra property here. So let's create the saloon class. So we have class saloon extends Opio, like that. Well, you can also use unisex saloon, like how it's in the paper. Just make sure there's no what, there's no space, like that. That will cause an error. It has to be one single word, but this is a very long word, and saloon also just, it makes the same, it brings out the same meaning. So you can just stick with saloon. Now let's do saloon. Saloon is also going to have a daily income. But how is this daily income calculated? You get the price of the service times the number of customers worked on. So if you had like a barber doing the haircuts, then you multiply the price of that service, maybe 5K, times the number of customers that got the haircut, maybe 10 or 20. So let's do that calculation. So first we have the daily income, like we had above in the timber. Next we have, because these are all whole numbers. That's why I'm using int. Next we have the price of the service. Let's use simple variable names. So I'm just going to say service price. Then the next thing we have is customers. So num of customers, short for number of customers. Now, how do I create? Oh, not how. Let's create the constructor for the saloon, which we shall use to create the objects of type what? Type saloon. And this constructor is going to take an integer for the service price and an integer for the number of customers. Okay. So this dot service price is going to be equal to service price, like that. This dot number of customers is going to be number of customers, like that. Then we shall get the daily income, referring to it like that. This dot the daily income is going to be the product of the service price times the product of service price and the number of customers, like that. So that's how we are going to get this daily income. So we have done a superclass and the two subclasses. Now the next bullet point, well, it is advisable to first read through all the bullet points before actually starting with the question, because there might be extra information down here. So let's do that. Your subclass must have a method that appropriately determines the daily income of that business based on the conditions above. So the method here that I used is the what? Is the special method, the constructor. So I used the constructor here in the timber class and the constructor here in the saloon class to get the daily income in both, like that. Based on the conditions above, the conditions that we deduced from the question. None of the values given above about Mr. OP's business should be declared as a local variable in your program. So none of the values that we were coming up with up here, the rent, the state council tax, the fixed price, the daily income, none of those values should be what? Should be declared as local variables, meaning what? Okay, the meaning here, what they want is we should use properties, like we've done up here for the spark class, like we've done up here for the timber, and like we've done up here for the saloon. So basically a local variable is something like this. This is a local variable because it is only applicable within the scope of this method here. So service price only applies in this method here. That's what they call a local variable. But these then become properties of the class. Basically, you can call them global variables because any other method down here can access them. So that's what they were testing for when they said we should not use any local variables in the program, or rather the values we came up with up there should not be used as local variables. Here we are not using these values as local variables because we are only using these ones that we came up with as the local variables. Everything else becomes a property. They are being used as properties, not local variables here. The fourth piece of information we have, fourth bullet point, your subclasses must capture input from Mr. OPO at runtime. Your subclasses must capture input, meaning you have to use the scanner. So in all the subclasses for timber and for saloon, we are going to have to use a scanner in both their main methods to capture input. And these subclasses must make a call to the overloaded method in their main. Now, what is this overloaded method? Remember, constructors are also what? Methods. So when you overload a constructor, you do something like what we've been doing here. You do something like this. This is constructor overloading. This is also constructor overloading. So basically we are overloading methods. We are overloading this special method called what? A constructor. Now how is this constructor overloading? It is because Java by default gives you a default constructor. So up until you define your own, Java uses a default constructor that has the same name, of course, as the class. So here, the default constructor, before we declared ours, like this, the default constructor was public timber, no parameters, like that. Actually, let's just do that. So that was our default what? Constructor. And then we were like, okay, we don't want to use the default constructor. We want to overload this constructor like this. That's what we did. Same thing here. The default constructor was public saloon, no parameters, empty body. That's the default constructor. And then we were like, no, we don't want to use the default constructor, this one. We want to use our own, which is this, which was overloaded. Remember, overloading. Overloading means same method name, different parameters. Remember, from where do we do that one? From here. A method signature is used to uniquely identify a method in a class. So same method name, different what? Parameter. The signature is different, which is exactly what we are doing here. So we have overloaded the method already, this one. Now let's make a call to the overloaded method in both the main classes. And that will be the end of the question actually. But let's also use the what? The scanner to capture input. So let's start with this guy up here, the timber. So after all that, I'm going to create a main method, PSVM, and create an object of type timber. Let's call this use simple things. Can actually call it T. Won't lose any marks there. This is going to be timber, like that. Now, by doing this, we are making a call. This is a method call. Remember from okay, yeah, I think we have something like that, but this here, this is a method call. This is also a method call. This is how you call methods. So we are calling this method here, but this is not a method they want, because they want us to use the overloaded method. And this is not the overloaded method. This is the default one that Java also gives us when we don't do anything with the constructor. So we want to use this overloaded method here. And by using it, we have to we have to input parameters inside here, which will become the what? The arguments for this method. And to get these arguments, you're going to use the scanner, which will let Opio decide what he wants the number of timber pieces to be and the price. So if I declare a scanner up here, This is a new scanner, like that. The source is system.in. Remember, every time you use the scanner class, you must import that package up here above your code. So import java.util.scanner up there. So what you're going to do, you're going to make this more verbose. So you're going to say enter the timber pieces. Okay, let's just call it the number. Okay, the number of timber pieces, like that. So we are prompting Opio to enter the number of timber pieces. Now, when Opio enters the number of timber pieces, what's going to happen? We are going to say get those pieces. We're going to call them pieces using that variable name pieces, and whatever we get from Opio using the next int method, because we are grabbing integers, or we are processing integers rather. Whatever we get from this method call, get whatever Opio enters and put it into what? Into pieces. And then these pieces are the ones we shall use here, like this, to construct our object. We've done pieces. Now let's do the price. So enter the price of timber. Enter the timber price. Enter the timber price, like that. So we are prompted Opio to enter the timber price. Then what? We are going to get that price. And whatever value we get from Opio using the next int, because we are processing integers, whatever value we get, we put it into what? Into price. And that price becomes what we are going to use when we are constructing the timber object, like that. So now we can see, remember we are calculating daily income for both what? The businesses. So we can say here int daily income. Daily income is going to be, it's an interesting one. It's going to be t dot the daily income, like that. Remember here there's some magic going on here. Okay, it's not magic, but we have this call to the constructor, and what this call does is it will run this code here. So what will happen is the pieces will become this, which will be set to this value, this variable name rather, and then the price will become this, which will also be set to this variable name. Remember, we have a variable name here called daily income as well. So daily income is going to be initialized using this product, the product of these two, like that. So we're going to get whatever is inside here times whatever is inside here to get the daily income. And all this is happening at what? At the moment of object creation. So it's all happening here on this line of code, this one here, object creation. So that by the time we have finished creating the object, we have already gotten what? The daily income. And how do you access the daily income? You get the object, use the dot accessor, and you access this property here. So I can just say here down daily income for timber, and do this like that, daily income. So that's a lot of code. Let's run it just to make sure. This is all the code you will need for the first class. Just this. we're going to run this to make sure we get a daily income for the timber class, for the timber business. So run this, enter the number of timber pieces. We are selling 500 timber pieces. At what price? Let's use a price like 5, so you know we are going to get 25 something. Yeah? So 15 gives us a daily income of 2.5. So everything is running smoothly for the timber business. Now let's go to the salon business. The same concept actually is going to apply. So I can just copy paste, but let's not copy paste. Let's come here, create a main method. Let's create some space. So create a main method like that. Create an object of type saloon, call it S. Is a new saloon. Now we don't want to use this constructor, because when we leave it like this, it will compile, but we don't want to use this one. We want to use this one. So same thing. Let's grab a scanner. Now to avoid doing the scanner twice, we can use the static trick, because here we are basically going to have to write the scanner again, but we can just declare a scanner, this scanner, outside of the main method. So we remove it from this scope and put it, we can actually put it here, but this is now just code maintenance. Like can declare it like that and then make it static like that. So we only have one copy of it in memory. So this code will still run, the one for the timber, because it was using the scanner. Oh, okay. Let's first do that. Run it again. So we should get the same results as we did before. But this is just to avoid rewriting the scanner again. So we have 500 timber, and each timber is 5,000, so we get 2.5 like that. So to avoid rewriting the scanner again, we can just get rid of this and just say prompt or PO to enter the what was the name? What's the name here? Rather here, service. Enter the service offered like that. The price. Enter the price. Enter the price. Service price. Enter the my goodness. Enter the price of the service offered. Like that. And to get that price, we say int price is equal to, we can reuse these variable names. Here we have price, and we also have price here, because these are local variables. They are scoped within, they are inside this block of code, so they don't exist anywhere else basically. That's why I can reuse them. So int price is whatever we get from the scanner, which is defined up here. Once. So we are going to use the scanner and the next method to process the price, the next int method, and whatever we get from there is going to be put inside price. And then we can use price here, because our constructor that we overloaded has a price here. So price is that. The next thing we want is the, what do we want? Number of customers. Enter the number of customers. We can stop there. I want to make it make sense. Number of customers worked on. Number of customers worked on. Like that. Get the number of customers like num of customers. You get that from the scanner object and the next int method. So this becomes what? Num of customers, like that. So when this code runs, this line of code, this is also what? Object creation. And remember what happens at object creation? This code runs because we're using this constructor that takes these two parameters. So this code will run assigning the price, this price to this service price. It will assign the number of customers to this number of customers, and then it will do the computation like this. So basically, by the time this code runs, we have the daily income already, which we shall get by saying we want int daily income to be s dot. We want to access this daily income, but this daily income is not pointing to this daily income of the timber class. It is pointing to the daily income of the salon class. So the two daily incomes point to the corresponding what? Class properties. This points to this, and also this daily income points to this one. Okay, so let's print this out like this and say, what did we say up there? Daily income for timber. So this is daily income for the unisex salon, like that, boop, like that, boop, like that, daily. Okay, let's run this code. I hate spaces, like that. Good. So let's run this to make sure everything runs as expected. We are going to have to enter the price, enter the number of customers worked on. So enter the price of the service. If it was a haircut, the haircut was 5,000. How many customers did we have? 50 customers. How much was that? 250,000 for the haircut. So no other fancy stuff is required. You can get rid of this. I was just using it to illustrate a point, but the code is not needed because by omitting it, you're still overloading. So you can omit the timber like that. Okay, so let's run it one more time. Let's first run the main method in the timber. Of timber pieces, let's go 200 this time. What price in Kuminya? This is 800,000. Good. Let's go to the salon business. Which service? The nail guys. How much is nail polishing because of it? Yeah, 10,000. How many? So many women. Maybe 40. And you get 400. So that is also working fine. And that is part 2. Done. No extra information is required. Oh, there, we didn't do anything with rent because they didn't ask us to do anything with the rent. Yep, that's all. So that's all for section A. Let's do the remaining questions in another video, or other videos rather.